Welcome to StackHawk office hours. Thanks for joining us. We're going to do the usual and just give it about a minute or two to let people trickle in. And while we're waiting, if you don't mind dropping in where you're calling in from, we'd love to hear where you're at. And we also have a poll just to get to know you a little bit. So what role do you play at your company? Nice. We've got a couple answers across the board: engineering, leadership.
Can people also, Nicole, can they type and just say where they're calling in from too?
Yep. You can type in the chat to let us know where you're calling in from.
It's less
Anything you want
scientific,
to
but always
say.
fun.
Yeah. Drop where I'm calling in from.
Yeah.
Barcelona, nice.
Oh, it does sound nice.
And tell us if it's warm in Barcelona right now.
I feel like I was just in Huntington Beach. That's near LA, isn't it?
Somewhat, like 40 minutes away.
Not hot, not cold. That's perfect. Sounds just like Huntington Beach.
Oh, Salt Lake City. I used to live there. I love Salt Lake.
Yeah.
I'm actually going to Utah in a couple weeks to go skiing, probably mostly Park City Mountain. I have a baby now, so I didn't get the Icon pass, but I'm missing.
Is Park City on Icon?
No, it's Epic, and that's
Okay.
where my in-laws live closest to. So it's like that's where the babysitters are at. So we just got an Epic so we can go ski Park City Mountain.
Oh, right on.
Yeah.
Yeah.
On.
But I do miss all the resorts on the Icon Pass for sure.
Yeah. Yeah, they're both. We had an Epic pass this year, but we also got a copper. We got 2 season passes this year so that we could go to all the Summit County mountains out just outside of Denver.
Nice. See, we got last year was the first year I ever got 2 passes. We got both Epic and Icon, and then I found out, and then I was pregnant, so I didn't get to use them.
Oh my goodness.
Yeah, that was a bummer, but maybe the day will come
Yeah.
again.
Well, should we get
All
into it?
right, yeah, let's get into it. So thanks again for joining us. If you just hopped on, go ahead and complete that poll. We'd love to hear what role you play at your company. We'd also love to hear where you're tuning in from, so you can drop that in the chat. Once again, this is StackHawk office hours. My name is Nicole Jones. I'm a product marketing manager here. And the topic today is prioritizing your SAST findings with Modern DAST. So we know that SAST is a great security tool, but can produce a lot of alerts. And there is a pretty slick way that you can work through those findings and prioritize them with Modern DAST. And that's what April, one of our solutions architects, and Dan Hopkins, our VP of engineering, are going to be talking about today. So I'll kick it over to them. But before I go, please don't hesitate to drop any questions in the chat or in the Q&A, and we'll answer those as we go along. You don't have to wait till the end. And you'll also receive a copy of the recording and slides afterwards. So over to you guys.
Perfect. Thank you, Nicole. And yeah, I mean, I think just to double down on what you're saying, this is supposed to be office hours. I think we've got maybe 10 minutes of slides, unless I talk for too long, but we'll zip through some slides and then, would love to hear any questions from the news or from the anyone that's watching. So as Nicole said, we are talking about how we can treat static code findings with DAST. So first up, we have a poll to just ask about everyone's familiarity with DAST. DAST is dynamic application security testing. And if you have used it before, we'd love to hear that. The problem that StackHawk was founded to do, and kind of what we see in the market, is this incredible acceleration in the way that the speed that people are working at. And originally this slide was really focused on the increase in API traffic. And then over the last 3 years, is that right now? Has it been 3 years since we started LLMs became really popular? I think so. We have seen now AI assistants and people building, entire, web architectures and applications for their mobile phones, all built using AI, where they have only maybe a passing familiarity about how the code actually works. Maybe they're programming on vibes. I'm not totally sure. But what we have seen is a large increase in how fast people are developing code. And in addition to that, the majority of internet traffic is being served over APIs. And so securing those APIs is one of the founding reasons for StackHawk. If you increase the velocity that you are developing code, less people understand what that code does. This is, and this has been happening over the last 30 years, even as we moved from waterfall development into agile development. And that really took the understanding of the entire system from an entire group, maybe a team of 70 people or however big your organization is. And it really brought down the understanding into a squad, or kind of an agile team, the two pizza team. And then that has been further accelerated with the development of microservices, and now finally with AI programming, we're seeing an increase here of velocity again. And the point is that when you are unfamiliar with code and you are unfamiliar and your release velocity is going up, you're creating risk in your system. Now you are all of a sudden shipping code that not everyone understands.
Yeah, it's like all of these great tools that have been built to help developers do their job better have also kind of made it easy for them to kind of gloss over what they're doing. So even just IDE auto-completion that's giving them suggestions about what to do next, and then of course Copilot, stuff like that, helping them, just generate entire blocks of code without really reviewing it very deeply, is really contributing a lot to this issue.
Yeah, I totally agree. It's a great point. And I like the analogy about just connecting this with autocomplete, because I think that's exactly what it is. It's just on steroids now. So let's talk about SAST and DAST, right? There's differences in the way that these two types of application tools work, right? SAST, static analysis, or static AppSec testing, application security testing. That really, it takes a look at source code and it finds common patterns that are known to produce vulnerabilities, and then it surfaces those up to the developers. So, it will look for, if you are not escaping your SQL correctly, it will notice that you are doing incorrect programming. So it is effectively like a really fancy spell checker. Like it looks for common patterns, or maybe a grammar checker, and tells you how it works. On the other side of things, dynamic application security testing actually takes a running application. So it's not source code. It has been either compiled or it's running inside of some sort of runtime, and it attacks the system and looks for vulnerabilities. So it behaves very similar to the way a pen tester would work, with obviously less creativity than a pen tester typically has, but it behaves on running systems and looks for vulnerabilities. And so really we see the difference between the two in false positives rates, and also the way that it gets the source or it gets the vulnerabilities. Keep losing my mouse. Our polls keep popping up. So why does SAST struggle in a new world of modern development? And for me, this kind of comes down to that an application is more than just source code, right? Source code is one component of the way that our systems behave, but really when you talk about an application, you're talking about the code that's been likely compiled. You're talking about the infrastructure, your AWS, all of your ELBs or EC2 instances, or however you're running the application and serving it to the world. And then the data that's behind it, maybe the user accounts, or, we always talk internally about the pants problem. If you were running some sort of e-commerce site and you had lots of different types of pants, that is an example of your data. And so if you only look at one piece of that, the source code, you can be missing an entire way of thinking about how to attack your system without the combination of the other two. And in fact, and this is typically why SAST comes up with a ton of false positives, that you take it from the security team and send it over to the engineering team, and the engineering team says, no, well, yes, this is theoretically a vulnerability, but it can't happen for XYZ reason. And maybe some of those reasons are the way that the data is structured, or there might be other reasons. The WAF might be configured in a way that makes that particular vulnerability impossible. And SAST has no ability to see the rest of the application. The other thing we've heard from customers is, and we've got this great quotation here, with the amount of tickets that come out of static analysis, they find that it's just an overwhelming problem for the security team. And someone told us in their estimation, they were, by running the static analysis on their code base, they found 2 years worth of work in order to fix.
And I feel like this is kind of ironic that SAST was one of the early tools that you were able to instrument into automation. And so it's been one of these automatic code quality checks that developers got used to in the early days, but it's so noisy that it also kind of trained them out of caring about security issues. And so kind of trained them to ignore those results in a lot of cases, which is an unfortunate side effect.
Yeah, absolutely. I have seen that. I've seen that firsthand at companies where the relationship between the two groups breaks down because there are so many vulnerabilities coming in, and they just lose trust that what they're seeing is real. Yeah, it's such a good point. All right. We know SAST is very common. For good reason. It is a great way to get started. So we were curious what everyone is using. Whoops. So then we're talking, so then the other half of this is not static analysis, but dynamic analysis. And in my opinion, this was a system of working that had a lot of promise, and it really won, or maybe it found more high value vulnerabilities, but ultimately it couldn't keep up with the way that modern teams are working. And so DAST really is all about provable runtime vulnerabilities, right? DAST can give you a set of steps that you can do against your running application that will reproduce a vulnerability. And the severity of that vulnerability is something that you would then take into account. But everything is from the attacker perspective. but it also has some weaknesses as a result of the way that it does scanning. It's harder to implement. It needs a runtime system to scan. So it needs something like a staging environment where you can do scanning. Traditional DAST also was meant to be run as a UI, maybe that sits on someone's computer and they click a button and say, attack this system. So very difficult to automate. And then because of this, maybe it's running on someone's laptop or something like that. It's really slow. And a lot of times people didn't care. They would run it over the weekend, hope that it finished by the time they came in Monday morning to look through the results, something like that. And it also, because a lot of this technology was built in the 2000s, it did not, and it was developed outside of engineering teams, it didn't keep up with the way that the engineering teams were evolving. So maybe traditional DAST really thought about the world in terms of HTTP and like the basics of REST. But there are new protocols that have been built on top of HTTP that we need to keep up with. GraphQL, gRPC, for example. And a lot of the times we're actually scanning in production, right? DAST, traditional DAST, really reinforces the mindset that the security team and the development team are two separate groups and they don't work together. And by doing that, oftentimes the AppSec team would find themselves scanning production because that's the environment they knew about, or maybe that's where they knew the users were or something like that. And if you scan production, every vulnerability you find is something that is already in the world. It's basically a security incident to find a vulnerability. And so you are reacting to the things that you're finding. And I think a lot of this is why traditional DAST has waned in popularity. Do you want to add anything, April?
Yeah, one thing I find really interesting too about that kind of legacy mindset and the idea that developers and application security professionals are separate and doing separate things. That production focus means that developers don't even see results until a long time later. And it also kind of reinforces this view of applications that the front end is what you're scanning. So I see a lot of people using legacy tools and they are pointing the scanner at the front end, but these days the front end is completely different from when DAST was originally created. Now, that's a single page app or even a mobile application. And it is not the target. The real target these days is APIs, REST APIs, GraphQL, etc. And you can't really crawl a single page app like you could in the old days with a PHP or a Ruby on Rails application. It just doesn't work that way. So, and so it just, I find that a lot of times when we go in, well, as StackHawk, when we go into some companies, the application security engineers there are often surprised when we turn up all of these APIs that are in their environment that they really didn't have an awareness of until we started to bring our tools in and help them out with that.
Yeah, that's such a great point. So how can we? I think I think what we were talking about is how do we modernize DAST and how do we bring it into the 2020s with modern technologies, things like that. And my belief is that this is moving out of, so you have two different types of testing, right? One type of testing is black box testing, which means you do not understand what's happening inside of the box. You just interact with the outside, kind of poke it, things like that. And then you have white box testing, where the box is not white, it's usually translucent or transparent. You can see inside of the box and see what is happening inside of it. And then you can test things by either manipulating the inside of the box or some combination of the outside and inside. Right? Those are the two general ways that we test things. There is a blend here where you might call it a partially transparent box or a gray box, And what that means is that when we do this dynamic testing from the outside, we actually understand more of the internals about what's happening. And so we understand we understand the microservice architecture that you're using, things like that. And by doing that, we can get more intelligent, more targeted scanning of what's going on. And so we believe that this is not just a choice of testing either by looking at the source code or by looking at a running application, that there is a hybrid of the two that we can bring to bear that will give us some of the benefits of both worlds. I believe that a modern DAST system really focuses on bringing together the security team and the development team. So it's developer friendly and allows the security team to understand exactly what's happening. So it should be wins on both sides. And along with that developer friendliness, it has to be fast. There are a lot of different checks that happen when you write source code. They've got unit tests and integration tests and all kinds of things. And in general, that build pipeline usually takes, call it less than 30 minutes to run. Otherwise, you're frustrating the engineers in the way they develop things. And so if the DAST scanner can run in 6 to 10 minutes, it can be a concurrent part of that process instead of running over a weekend.
Yeah.
Do you have anything to add, April?
Yeah, that speed really makes a difference in how you can fit this into testing. So if you can get it into 5 minutes or so, then it's a candidate for testing even on a pull request, which makes it very, very useful to developers. So imagine a developer proposes a code change, and now they can know in 5 minutes that if their code change has resulted in a new vulnerability. That context awareness, where the developer just wrote the code and was told that it created a bug, is super helpful. It makes it pretty straightforward for them to understand and fix that bug.
Yeah, absolutely. And then I think the last piece is here, let's talk about prioritization, right? Is if you have a bunch of these vulnerabilities from DAST or SAST, how do you actually understand which ones of them are exploitable and therefore are really high risk? And that is something that DAST can bring to you by in addition, by first of all showing you how to exploit the vulnerability. That's one of the benefits of DAST. But then even more than that, by helping you tie that from the HTTP calls, kind of the API interface, all the way back to the source code. And our product actually can correlate things from the front end to the back end. Carlos asks about IAST, or interactive application security testing. And I do think this is it is a slight evolution of DAST. It has an understanding. It oftentimes is instrumented inside of the application server itself, and then kind of sees what's going on at a code level, at least in the running application. I have not seen a lot of new startups coming out that are doing like true IAST. So I think it could, in theory, be an evolution of DAST, but I haven't seen it manifest that way. What are you seeing, April?
So yeah, I've seen that it has not been really a big contender lately from what I have seen in talking to customers and folks who are checking out StackHawk. But I think what IAST is trying to get to is this idea of a runtime vulnerability, so a known runtime vulnerability, and being able to trace that all the way back to a line of code. But you have to do all this stuff with IAST. You've got to build in libraries, you've got to add stuff to your code, and it becomes kind of complicated. And we think we kind of have an approach that we are starting to get towards here that does the same thing. We want to find a runtime vulnerability and see if we can tie that to a line of code, but in a way that doesn't require that much additional work on your application just to enable that. And
Yeah, thank you.
yeah.
All right. So how does StackHawk help with a lot of this, especially in the prioritization? And I kind of hinted at it on the last slide that really what StackHawk can do is automatically correlate the SAST findings that you're getting with the DAST findings that you're getting. So connect the two of them so that you really get the benefits of knowing that a vulnerability is exploitable, and but also understanding where in the code, and potentially getting an auto fix suggestion from tools like Copilot. And the irony of AI fixing AI is not lost on me, by the way. But I think that's one of the really great benefits of AI is once you ask it to, hey, that's not right, can you fix yourself? And then it will happily say, oh yeah, sorry about that, here's a completely different way to do it. And we have a one of our customers working at a supermarket is talking about the connection between StackHawk, DAST, and SAST over here, and how the integration, has really allowed them to help prioritize the SAST findings that they were getting. And when we see customers do this, we have seen, the already pretty low false positive rate that comes out of DAST go even lower, and really seen that drop on the SaaS side, where we're typically ignoring a lot of the findings, and we have seen increased fixes, I think, is the other side. Anything you would add to that, April?
No, I think that's it. It's really something that makes itself plain once you run into it and you see it in action. But we actually think that, or I actually think that, whereas sometimes people try triggering pull request breakage or test failures on SAST results, there is so much noise that that's really hard to do. But now if you can break on a DAST finding, which is more of a runtime provable, reachable vulnerability, that's a little bit more appropriate in my mind, because it's so serious and so easy to prioritize that fix. But then it lacks that code level context. And so if you can pull in a SAST result that is exactly correlated with that, you really start to see the benefit, and it becomes very, very easy for a developer to fix.
Yeah.
Maybe I should just show it.
Well, let's, if there's not any other questions, why don't you give us a demo about how this works, April?
Sure. Let's go. All right, so I have my code base for this Java Spring Vulny application. It's in GitHub, like most code in the world is. And for this one, I've opened up a simple pull request, and it's called the StackHawk pull request demo, because I just changed a couple of things in this, mostly just to create a PR, but some of these are actually some real code changes that I should submit one of these days. Anyway, this is what a pull request looks like. So developers are opening pull requests all the time. And like I say, basically what it is a developer says, hey, I've got a couple file changes I want to move towards production. So I'm going to open a pull request. And when that happens, I can get a bunch of checks done on my software. And that might include SAST, and it might include DAST as well, with StackHawk, for instance. But once all those checks pass, I can also get my peers to look at the code and analyze it themselves and sign off and say, yes, this should move forward and go to production. And that process really has added to the quality of code. It's been through a lot of checks and a lot of human eyes before it makes it to production. So this is that journey. And in this pull request, often developers will comment on the code and say, here's, I like this, but you might try doing it this way because this is a little bit simpler. You might also have automated tools posting responses to the PR. And StackHawk, for instance, can post a response that says, hey, part of the checking process was to run a scan against this this application. We fired up the application that you just made some code changes to, and we ran a DAST scan against it, and we found some issues. And in this case, I had set a threshold that says, hey, if I find any new high criticality issues, something really serious, I actually just want to break the build. I want to break the PR and stop it in its tracks. So I can't even move on to peer review. Nothing's stopping my peers from reviewing it, but I probably won't even tell them about it until I've resolved this issue. So I've got some checks were not successful, and most of my checks were fine, but HawkScan or StackHawk has posted an error. And so as with any of these other checks, this is a link to the actual scan results or the test results. So I can just click through here and see what went wrong. And when I do that, I'm presented with this pretty clear, I think, interface that shows me, all right, we've got a test result against your Java Spring Vulny app. And this happened in GitHub Actions. And what we found is that you've got a number of low and medium findings, but also this SQL injection finding, which is a very serious issue to contend with. And not only have we found that, we've found a number of them. We've found 6 new results in this category. And we also have this icon in the SAST column in this case, and this is where that correlation starts to come into play. So what I've done in the background in my pipeline is I am running DAST scans, but I'm also running CodeQL, GitHub's CodeQL static analysis against the same code base every time I open a pull request. So I've got results from both. And what this is telling me is that I've got a correlated finding from the static analysis. I've got a dynamic result and a static result. So here is the detail of this vulnerability. I've got some remediation advice explaining how you can fix this. I've got this list of routes in the API where this vulnerability was found. So several times on the search path, and then also in an Okta and a multi-form page where this vulnerability occurs. And for this top one, for instance, I've got a request and response that says, hey, made a request and I was able to use some gray box techniques to know that, you know, this particular endpoint expects a JSON request body and it expects this search text field. And so I dropped a single quote into that search text field. And that's often the start of a SQL injection vulnerability. And the response that I got back was that we created a Postgres exception. And so that, in this case, is pretty clear evidence that a SQL injection vulnerability is possible. And we can validate it. This is kind of showing off some StackHawk features, but we can generate a curl command. So that's a command line based web browser, essentially, that we can use to recreate this attack. So that's something that a developer can bring back to their own workstations and start reproducing this vulnerability, verifying it for themselves, and starting to work on a fix. So that's all awesome. We know this is a runtime vulnerability. We know it's reproducible, and we can help a developer reproduce and fix it, but we can't on our own show you the line of code where this happened, but CodeQL can. And so what we've done is we have, remember I ran CodeQL on this pull request as well. And so when I ran the DAST scan over here, we found that this vulnerability is a common weakness enumeration number 89, aka SQL injection vulnerability. And static analysis does that too. Most static analysis tools will also look up the CWE as well as a CVE when they can. And so we've just basically matched on CWE, and now we can say, hey, GitHub CodeQL is implicating these 2 files, searchservice.java and user-search-service.java in my code base. So you, dear developer, should look at these 2 files, and you should look in the vicinity of this code snippet for the vulnerability. And as you can see, that kind of marries the best of both worlds. We've got dynamic runtime results showing you that this is a reachable, exploitable vulnerability. And you've got static analysis that shows you there is a pattern that can lead, there's a code pattern that can lead to this runtime vulnerability. And here's where it is. So that's where you should start looking to fix this. And then in the context of a PR, the developer just wrote this code. So they should be pretty familiar with where this popped up. And of course, you can jump out to the details and look at what CodeQL has to say about this. And they will point out that you have executed a query using information from a variable that was provided by a user. So a user inputted some data, and then you just drop that into a query against a SQL database. And you didn't do any checking to see if there were escape characters that could be used for attacks. And so that's the root of the problem, and that's the reality of this vulnerability. So if you were to follow this advice and maybe even just let Copilot automatically fix this vulnerability for you, Copilot here is going to generate a fix suggestion, and we can just fix this right in line and resubmit this back to the pull request and rerun all those tests. And when we do that, we should get a fix, and that PR should now pass through to completion. Which I won't do because it'll probably take 10, 15 minutes to go through the full process. But that is the idea, and that's sort of the advantage of using these two tools together and correlating them. Not only do we have two tools telling us you've got the same problem, agreeing on the problem, they have this really nice complementary set of characteristics: exploitability and code insights.
Yeah, very good. I was I was wondering why CodeQL is so emphatic that that's user created.
Yeah.
It like said it 5 times. I thought that was funny. AI must be going crazy. Let's just recap, and then we've been taking questions throughout the whole thing, but happy to take another one. I think the the biggest things we want to recap here are that number one, the real-time security feedback. So like the ability of the security team to understand that things that are going to production are secure as they get shipped, is really means that the tools need to be able to keep up with rapid development. This is so critical, even more now than it has been in the past, when more code is being developed by non-humans with less judgment potentially than the engineering team, things like that. I think we talked a little bit about the trade-offs that you get by looking at source code versus looking at a running system. So SAST, static analysis versus dynamic analysis. And then just like Corn and Cotija, if you mix the two together, SAST and DAST, you can really help to understand not only all the entire body of all the vulnerabilities, but actually the priority that you should go and fix them. And also, elote is delicious. That was the other thing. And now I'm very hungry after this presentation.
That is the key takeaway. It is about lunchtime.
All right. Well, I'll just stop the share, and if there are any questions, would love to hear them.
Yeah, we've got one from Karina Blair. Do you plan on integrating with more SAST tool offerings outside of Sneak and GitHub CodeQL? And we have talked about some for sure. Yeah.
Do I have to answer as the head of engineering?
As the head of engineering, I think it's appropriate for you to answer this one.
To answer this question. It is a great question. I appreciate it, Karina. Frankly, we snuck in a question at the beginning of this to help us prioritize our roadmap, to ask you what SAST people are using. We occasionally hear, I'll just be completely transparent and say there's nothing currently on the roadmap. But we do hear from customers every once in a while about SonarQube, and maybe a couple of the other ones are somewhat popular.
I hear SemGrep come up a lot.
And SemGrep, okay,
Yeah.
yeah, we're actually good friends with the SemGrep team. We've done a couple of co-events with them, and we have talked about ways to bring our products together. So it's good to hear. At the time when I talked to them, it was more, SemGrep was more for like like companies that were just getting started in security and they weren't yet thinking about DAST, but I suspect that is changing every day. So yeah, I could, SemGrep, SonarQube, those are the ones we've heard, but vote for your favorites in our poll. So the short answer is we do not have anything yet on the roadmap, but we would love to talk to you.
I'm curious if anybody out here, I can't believe we made it through this webinar without mentioning, or maybe we did and I missed it, vibe coding. And is anybody picking up on this trend? Vibe coding, which is like taking any of these AI tools like Copilot and just basically giving it comments to say, hey, build me a function that does this. And it auto suggests and you accept the suggestion. Maybe you look it over really quickly, but quickly move on. And people have written entire applications with this method. And so by the end of it, they barely have any familiarity with the code base, which I think that really, really clearly illustrates how important it is to be doing really good testing and automated testing of all kinds, but especially security testing in your automation process. And I feel like some of our AI generated images are also good examples of why you want to test. I found a lot of Easter eggs in our AI generated images. Like
Yeah.
angry corn.
What did you notice, April?
Well, I noticed really angry corn cobs out of the corn. And I'm from Iowa, so I know that corn plants don't look like that. They don't have a giant corn cob head. They've got little corn cobs on. Anyway, I just thought that was kind of ironic.
Yeah, there you go. When the hallucination starts with the AI tools, imagine what it does in code. And this is
Carlos asks, I saw in the slides DAST as dynamic API and application. What are the overlaps with tools like No Name? That's a great question. It's a great question because we didn't even talk about API discovery, which is kind of the overlap between these two kinds of tools. No Name is a tool that is often used for API discovery, and the way it works is you install these agents out in your production environments, and they listen for traffic, and they try to discover where the APIs are that this traffic is coming from and going to. And we also have an API discovery platform, but our approach is to look at code bases instead. So we look at your code repos. You can plug us into GitHub, into your GitHub organization or Azure repos organization. And we can just look through your code base and say, well, this repo has an API and this repo has an API. This one does not, this one does not. So that's kind of the overlap, but we think that obviously we're biased, but we think that the code base is the real source of truth for where your APIs are and which ones you should have under test, rather than trying to figure out where in production you can stick a sensor that will discover all of your in production APIs.
Yeah, totally. I think the only thing I would add to that, typically No Name is considered a runtime protection tool. And so just like April said of the mechanics about how it works, it's really about protecting production. And the ST in SAST and DAST are about security testing. And so it should be about preventing the vulnerabilities from actually going to production. No Name also, I believe, has some testing capabilities. I've not heard of customers that actually use it, and I don't think it comes up as a serious competitor to a dedicated tool like ours. But yeah, that's kind of the differences I see.
Great questions.
Yeah.
All right. If there's nothing else, should we wrap this up and give everyone some extra time back? Another 15 minutes to start lunch. Go grab some elote.
Yeah. I mean, we have people from around the world, so it might not be lunchtime for everyone, but
Fair point. Maybe dinner, maybe
maybe dinner.
breakfast.
Yeah. Very good. Well, thank you everyone for coming. It was good talking. Really appreciate the questions and hope the content was good. And yeah, we will be in touch, I'm sure.
Kakao.